Hi guys, higher maths, exercise 15b from the recurrence relations topic. So I'm going to go over question 4 and 5 here. So the thing to do here is, well, say on every single question, I suppose, read the question very carefully. So a generous relative puts £100 into a bank account when her granddaughter is born on the 2nd of April. On every subsequent birthday, the relative puts another £50 into the account. Interest at a rate of 0.5% per annum is credited to the account on the 1st of April. So that's basically just before the granddaughter's birthday the following year. From a recurrence relation including the first term U0, form a recurrence relation including the first term U0 to model this situation. So what's happening is the granddaughter is receiving a 0.5% increase on her money each year. So she will have 100% of what she's got, and then she's getting 0.5% interest. So that'll be 100.5% or 1.005 times as much as what she did have. So when setting up a recurrence relation, our multiplier, or our coefficient of UN, will be 1.005. So this works out a 0.5% increase on the previous amount. And in addition to that, the relative puts another £50 into the account on each subsequent birthday. So then we're going to be adding on £50 each time. And the initial amount put into the bank account, which would be U0, is £100. So if we think about how this works, U1 would be 1.005 times U0. So basically, after a year, there's going to be an extra 0.5%. Okay, so we'll get an extra 0.5% on the £100. That'd be an extra 50p. Plus the £50 the granny is going to put into the account afterwards. So it'll be £150, 50p. Then to calculate U2, the amount after 2 years, it'll be 1.005 times the £150, 50 pence, add on the £50 again. Okay, and we're just kind of getting to a loop, and we'll just keep on doing that loop to get U3, U4, U5, U6, etc. Okay, so there'll always be a percentage increase or decrease, and then most of the time we're adding or subtracting something after that. And always stay U0, the initial amount. Question 5. At a big game conservation park in Africa, an elephant needs treatment and is injected with 500 milliliters of anesthetic. So that'll be the initial amount, or U0. It is known that 15% of the anesthetic wears off every hour. Okay, so a 15% drop will leave us with 85%, or 0.85. So the elephant is given a booster of 40 milliliters every hour, form a recurrence relation, including the first term U0 to model the situation. So each time the elephant will have 85% of the anesthetic that it had previously, so it'll be 0.85 times the previous amount, plus the 40 milliliters that it's been given in its top-up booster. So to get the next amount, it'll be 0.85 UN plus 40. So if we wanted U1, it would be 0.85 multiplied by 500 plus 40. So basically the anesthetic's wearing off, so it's getting a 40 milliliter boost each time to work it out. Okay, I hope that was useful.